Hi everyone, we'll wait for a few more minutes and then start with the class. Hello, good evening everyone. I hope I am audible. I welcome you all to the GRE Preparation Made Easy Quantitative Reasoning classes by Mrs. Abida Banu. So here are a few instructions for the participants. Make sure you have a stable internet connection and a noise-free environment. We recommend you to use your earphones for best experience. Also respect your instructor, your classmates, and yourself. Do not write inappropriate things on a chat box. We have three packages: bronze, silver, and gold. You can register for free for the bronze package. To upgrade in silver and gold, you will get extra benefits like evaluated mock tests, personal recommendations, expert university recommendations, and so on. We also have free profile evaluations with our experts, comprehensive evaluation, university shortlisting, course recommendations, recommendations reports, and doubt clearance. You can contact our website for any doubt. We also have free live IELTS classes from Monday to Friday, 7:30 to 8:30. It is a 4-week course. Also Duolingo classes. It is a 2-week course from Monday to Friday, 6:30 to 7:30 p.m. Also, we have this Ubergrad loan fair. It is on 7th October. You can register for free. You will get benefits like personalized loan assessment, instant loan offer, discounted processing fees, cashback incentive, and so on. It is for free. Please do register. It is this Saturday, 7th October. Also, there is a special price for our gold package that starts from rupees 499, and you get the various incentives shown here. These are few achievements. This is the Ubergrad website. You can select your country, course, specialization, and when you go on explore, you can select the countries, universities, courses, exams. You'll get all the information here on the website. When you go on solutions, you get help like free profile evaluation, talk to the counselor, country recommendations, test preparations, additional services, also blogs. Weekly blogs are uploaded. Do go through them. And this is the fair page, our virtual loan fair. Timings are from 5 p.m. to 8 p.m. It is free of cost. We've partnered with various banks like ICI, IDFC, Axis. Also, these are the additional benefits you'll get. Also, when you go on my test preparation, second, you get our recordings and handouts for quantitative reasoning, geometry. All the handouts and recordings are uploaded time to time. Like for triangles, just a second. See, the recording has been uploaded and you can go through it if you've missed any lecture. So that's it. For any doubt, please share it on the chat box and we'll get to you. Also, I welcome Mrs. Abida. You can please take over. Good evening, ma'am.
Good evening. Thank you. Good evening, everybody. Myself, Abida. So I'm a quantitative reasoning trainer. The session today is regarding the circles and solid figures. First of all, please confirm whether my voice is clear. I'm audible to everybody. Yes. Yeah. Yeah. I hope I'm audible and my screen is clear to everyone. Right? If there is any issue regarding, just send a message in the chat box. Okay. Right. Yeah. The session today is regarding circles and solid figures, solid geometry, right? Solid figures. So first basic thing regarding the circles. So you can see the figure here on the screen. It's regarding circles and there are many parts of the circles which are represented on the figure, right? Starting with the center. So first let us take a basic information regarding the circle. What is a circle? What is a circle? Yes, circle is a figure, right? So it's just a figure which gives all the points equidistant from the center. Whatever the point I draw from the center to the circumference, all the points will be equidistant from the center to the circumference. Such a figure is called as a circle, right? Starting from the center, this point we call it as a center, and the complete thing from here to here, this is a diameter. And the half of the diameter we call it as a radius. Half of the diameter is radius. Okay, you can see here the radius. Okay, and one more thing, the card of the circle. Next thing is card. Card is nothing but a line which is joining the circle with for the circumferences inside the circle. And next thing is secant. Secant is the line which is passing through the circle, which divides the circle in 2 points, right? From here and here, you can see that. So this line we call it as a secant. Okay. And next, arc of the circle. Arc is nothing but a circumference. If there is this part, you can see the part over here which is drawn. This we call it as an arc of the circle. Tangent is nothing but the line passing through the circle, touching at one point. From outside the circle, we call it as a tangent. Okay, these are the basic parts of the circle. And important thing is sector. Sector of the circle is nothing but the portion of the circle which is bounded by the arc. Bounded by the arc and two radii. We call it as a sector. I repeat once again, sector is a portion of the circle which is bounded by two radii and the arc. We call it as a sector, right? Which is seen here as a pizza slice, right? So this we call it as a sector. And segment, in the sense, it's a region bounded by chord and the arc. The region bounded by chord and the arc, we call it as a segment. Okay, these are the basic parts of the circle. And very important thing to know about the formulas related to the circle, the basic formula is area and circumferences we should know. So the area of the circle is pi r square and circumference of the circle will be 2 pi r. Circumference is nothing but the complete boundary of the circle. As we do perimeter in the rest of the figures, circumference is nothing but the boundary, right? Okay. Let's start with the questions. So this is all about the circle and the shapes of the parts of the circle. Now I'm going through the question part. So starting with the first question here, please try to give the answer for the first one and second one. A circle has an area of 16. What is its circumference? Keeping in mind with the formulas of area and circumference, we can do this question here. Question number 1. Once you are done with, send your messages in the chat. Yes. Yeah. Difference between secant and chord. You can see the difference here. Chord is a line passing through the circle. Within the circle, secant is extending towards the outside. It's extending, right? The line is cutting the circle from outside. So that is the difference between the secant and chord. Chord in the sense which is dividing the circle inside. Secant is moving from outside. You can see the line here which is coming from outside. Okay, right. So here it is, the area of the circle has an area of 16 pi. There is a typing mistake. You can rectify. 16 pi, what is the circumference? So 16 pi is the area. We know the formula, it is pi r square, right? So to find out the circumference, we need to know the radius. So from here, we can find out the radius. Cancel the pi's here. Okay. It's 16. Cancel the pi's. R square is equals to 16, then r will be 4. So if the radius is 4, 2 pi r, so it will be 8 pi. 8 pi will be the answer for the first one. Moving on to the second question. The circle has circumference of 20. What is its area? Now circumference is given, that is 2 pi r is given. And we are asking to find out the area pi r square. So 2 pi r is given as 20, right? So 2 pi r is equals to 20. Then what will be the r here? 20 pi actually. So pi is missing. There is a typing error. Please make a note of it. So it will be 20 pi. So cancel the pi's, 2 ones, 2 tens. So the radius will be 10. If we are getting the radius, it's very easy to find out the area, right? So pi into 10 into 10 whole square, it will be 100. Moving on to the next question in the next slide. Yes. So here also pi. Please make a note. The circle has a circumference of 8 pi. What is its area? Waiting for your answers. Yeah, the previous one was 100 pi. Give me the answer for the present one. Yes, it's 16 pi. Next, question number 4. The circle's area equals its circumference. What is its radius? Area is equals to circumference, it seems. Then what will be the radius? Area is equals to circumference, right? So we know the formula of area, pi r square, circumference 2 pi r. What are the things we have to cancel here pi and r. So pi and r. So r will be 2, right? The radius will be 2 here. Next, moving on to the next slide. So that was the basic stuff regarding the area and circumference, pretty easy one. Now next, properties of circle. So if you talk about the properties of circle, the first thing we should know about there is a relationship between the length of arc and area of the circle. You can see the circle, right? So here there is a circle, there is a sector shown here, and arc length. The basic questions will be asked related to this concept is to find out the arc length of the circle and to find out the area of the sector. So these are the formulas what we are going to use throughout the session here regarding for the questions related to arc length and area of the sector. So whenever the question is related to arc length to be find it out, then always we need to keep in mind uh, the angle is to be measured in degrees, and arc length will be theta by 360 degrees into 2 pi r. Theta is nothing but the angle, right? So whatever the value of this angle is given, that we will represent here. If it is 40, so here it will be 40 by 360. If it is 90, 90 by 360, whatever it may be, right? So theta by 360 into 2 pi r. What is 2 pi r? 2 pi r is our circumference, right? So this arc length can be considered as theta by 360 into circumference, and area of sector can be considered as theta by 360 into area of circle, circumference of circle and area of circle. Pi r square is area. Whenever the degree, whenever the angle is to be measured in degrees. Now, there is another way of measuring the angle. It may be in radians, right? Whenever it is being measured in radians, the arc length will be always theta into r, that is radius. And here the area of sector will be half r square theta. Okay, these are the two things you should keep in mind. Whenever the angle is to be measured in degrees, we use the formula for arc length, theta by 360 into circumference, and area of sector will be theta by 360 into area. Area of circle, actually, here we are going to take. I hope it's okay. I'm moving on to the question, right? Yeah, you can see the question here. In the figure below, point O is the center of the circle. The radius of the circle is 8. What is the area of the shaded sector? We have to find out the area of this shaded sector. Okay. Now, we know the formula of area of sector. What is area of sector? Area of sector is nothing but theta by 360 into pi r square. Theta by 360 into pi r square. Now, theta, what is theta here? Theta is nothing but the angle, whatever the angle here it is. By seeing the figure, you can assume the box symbol. If you identify the box symbol here, the box symbol always represents 90 degrees, right? That's a right angle. The angle here is representing the right angle. So it is a 90 degrees. So theta is 90 degrees here. 90 degrees by 360 into pi r square. So r, radius of the circle is given in the question, that is 8. Pi 8 square. So here it will be 0 zeros gets cancelled, 9 ones 9 fourths. So 1 by 4 into pi of 64, right? Final answer, please. Final answer for this question. Yes, it's 16 pi. Correct. It's 16 pi. The answer for this will be 16 pi. I hope you get the answer, right? So moving on to the next question. The question is for you guys. Some time, try to do it and let me know the answer. I'll write down the formulas for your reference here. Area of sector, theta by 360 into pi r square. Arc length, or length of arc, theta by 360 into circumference of the circle, 2 pi r. Represent the answer in the options like A, B, C, D, or E. Don't write the answer directly. Represent it in any of the alphabets like A, B, C, D, or E in the chart box. Take some time. Give me a correct answer once you're done. Yes. So here you can see the diameter is given in the question. So we need to find out the radius. What will be the radius? Radius will be 7. If diameter is 14. The radius will be half of the diameter, right? So radius will be 7. Now what will be the circumference? If radius is 7, then circumference, total circumference of the circle will be 2 pi r, right? 2 pi into 7. So 14 pi. So it will be 14 pi. Now we need to find out the arc length. So arc length, what is the measure of the central angle of the sector in degrees? That is the question he is asking for us. So first thing, the diameter, we know everything. So to find out the arc length, so we just go through this. 7 pi is equals to, actually this is 7 pi, not 7. Just make a note of it. So pi is missing somewhere in throughout the representation. If I miss to explain, please raise a thing in the chat box, that reminder like that, so that I can identify, right? So a sector of a circle has an arc length of 7 pi. It's not 7 actually, it's 7 pi. Okay, if the diameter of the circle is 14, then what is the measure of the central angle of the sector in degrees? So we need to find out the value in degrees. So first thing we should know about the formulas of area of sector and arc length. Area of sector is theta by 360 into pi r square. Arc length is theta by 360 into 2 pi r. Now, first thing is finding out the circumference of the circle. Overall circumference of the circle will be 14 pi. Now, as per the question, he says it's the arc length is 7 pi. So, it's very easy to go through that. One clue, we got one clue here. So, theta by 360 into circumference, right? What is the circumference? The circumference is 14 pi. 14 pi. Right? I hope you can solve from here. Waiting for the final answer. It's 180, correct. 180 is correct. Right. If you want to find out the value of theta, central angle is nothing but the theta value here. So we can just find out the theta here by 7 pi gets cancels here 1 times. And here we can cancel it for 2 times. Right? So 2 theta is equals to 360. Then theta will be 180. Right. Next question. Question number 3 is on screen. I think you can answer this one. Similar question. So if O is the center of the circle, what is the perimeter of the sector with central angle 72 degrees? We need to find out actually this perimeter of the sector. So whatever the sector, right? So we need to find out the perimeter of the sector. One angle is given and radius is given. So finding the length of arc. So first of all, find the length of arc. You know about perimeter. Perimeter is nothing but sum of all sides. Gives you the perimeter. Find out the length of arc first. What is the length of arc? Theta by 360 into circumference. Right? Theta by 360 into 2 pi r. R is 5. It's mentioned here. Radius is 5 mentioned. So 2 pi r. Now theta by 360 into 2 pi r, that's nothing but theta by 360 into 10 pi. Okay, so central angle is 72. So directly put 72 over here, 72 by 360 into 10 pi. By cancellation, so you can say 72 ones, 72 fives. So it will be 5 ones, 5 2s. 2 pi. The value of this will be 2 pi here. Now what will be the perimeter? So radius, if the you should note one point here. Wherever there is a circle, the radius will be same. I told you, from center, whatever the points you take for the circumference, all that will be equidistant. So whatever the points I am taking on from the center to the circumference, all the points will be equidistant. So if it is 5 here, then this point also will be 5. So we got two values and we need to find out the length of an arc. So to find out the length of an arc, we had the formula theta by 360 into 2 pi r, right? By using that, we had find out the length of an arc is 2 pi. Now it's very easy to find out the perimeter of the sector. What will be the perimeter of the sector? Put it in the chat box, waiting for your answer. Exactly 10 plus 2 pi. 5 plus 5 plus 2 pi. It's nothing but 10 plus 2 pi will be the final answer for this. Okay, moving on to the next question. Yeah. So here, actually the previous property was related to length of an arc and sector area, right? Length of an arc and area of the sector. Now the next property of the circle here, chord and arc. Properties related to chord and angles. So you can see the figure here. So whenever there is a chord drawn, what are the properties related to the chord and the circle? The first thing is, let me draw one figure for you here aside. The first thing, let us say this is a circle and this is the chord and center. From center, we can say that from center it is giving you perpendicular. Exactly, the value of this will be perpendicular to the chord. Okay, center, we have the points which are perpendicular towards the chord. And let us name it A and B. Okay, let us name it A and B. That means these two are perpendicular from the center. AX, let me name it as AX is equals to BX. That means the length of these two will be equal. AX will be equals to BX. If you want AB, then what will be the value of AB? AB will be the sum of AX plus BX. Got it? So AB will be the sum of AX plus BX. So one thing we need to know here, whenever there is a chord drawn on the circle, from the center it is a perpendicular. Whenever there is a perpendicular, we all know that the angle formed here will be 90 degrees. So these are the 3 points you should know. The first thing is the perpendicular, and second thing is the angle will be 90 degrees, and third thing is the values, the length of this chord. Whenever we see that, it is like bisecting. The same values will be there. AX is equals to BX. If you want to find out the value of AB, then sum of AX plus BX will be the value of AB. Next thing. Next property related to chord length. So how to find out the chord length? To find out the chord length, we use the formula 2 into, it's like 2 into root of R square minus D square. 2 into root of R square minus D square. Please make a note of this. 2 into root of R square minus D square will be the value of chord length. Now moving on to the next slide, we have some more properties related to this. So I'm just zooming it because I feel that it's a little, yeah, right. The central angle is twice the inscribed angle subtended by the same arc. Okay, so if you see the central angle, first figure, if you concentrate on the first figure, inscribed angles subtended by the same arc are equal. Inscribed angles subtended by the same arc. You can see this thick line, right? So you can see this thick line. So this is an arc. So this is an arc, and these are the inscribed angles which are formed on the same arc. You can just recognize this one, right? So all the same arc, whatever the angles formed over are same. For example, let us say this is 40 degrees. Angle X degrees, angle Y and angle Z you need to find out. So what will be angle Y? Angle Y will be also 40, angle Z also will be 40. Why? Because there is a property called inscribed angles subtended by the same arc are always equal. So if you see the arc, if there are any inscribed angles formed in the arc, the length of that inscribed angles, the measure of that inscribed angles will be always equal. Moving on to the second point here, angles subtended by the diameter our semicircle is 90 degrees. Okay, so angle subtended by the diameter is 90 degrees. So whatever the angle here it is, the diameter, we can say that it is 90 degrees. Angle on semicircle. Angle on semicircle, you can say that. Diameter is semicircle. Angle on semicircle is 90 degrees. Can you tell me what is angle of semicircle? Angle of semicircle. Anybody waiting for your answer? Quickly put it in the chat box. Angle on semicircle is 90. What will be the angle of semicircle? Shall I repeat the question once again? Angle in semicircle is 90. Angle of semicircle will be what? Angle of semicircle will be 180, not 90. Okay. Angle in semicircle. Angle in semicircle is 90. Then angle of semicircle will be 180 degrees. Got it? Right. Next. Central angle is twice any inscribed angle subtended by the same arc. So I'll just move it towards downwards. Yeah. Central angle is twice any angle subtended by the same arc. So in easy language, I can even say that whatever the angle formed in the circumference, the central angle will be twice for that. For example, let us say, consider a simple figure. So this is a circle, this is a center here. Okay, I'm just drawing a figure which is shown on the left side. Same figure. Let us say this is some value of this is 20. And what will be the value of this? This will be 2 times of this. That's nothing but the angle subtended by the card at the center. You can see that it will be the card here. If you draw that, it will become a card like this, right? So it will be doubling the angle at the center. Whatever the circumference, the angle we have, that will be 2 times at the center. If it is 20, then it will be 40. Okay. The same thing in the second figure also. Moving on to the questions related to this concept. You had the question number 1 here. I'm decreasing the screen size. Yeah. Give me the answer for this. If the diameter of the circle is 36, what is the length of arc ABC? Diameter of the circle is 36, length of arc. So it's been asked over there. Diameter is 36. What will be the length of an arc? So we know the diameter is 36. What will be the radius? Radius will be 18. What will be the circumference? 2 pi r. 18 into 2, right? So 2 pi r, it will be 36 pi. Circumference will be 36 pi. Now, you can see that whenever we are talking about the length of an arc ABC is a major arc, the bigger one. And another arc here, you can see this arc, this is a minor arc. Minor and major. Major arc in the sense the bigger one, and minor arc is a smaller one. You can see this arc is a smaller one. And what is the length of arc ABC? We have to find out the length of arc ABC. So length of arc ABC, first of all, you just find out the minor arc. So because we had the central angle here, the angle of that has been given, so it's very easy to figure out. So what is that? We always know that whenever it is 40, the central angle will be double to that, right? If theta is equals to 40, then the central angle will be 40 into, so this figure can be identified in this way. Okay, so this will be double of this, so it will be 80. So this part will be 80 degrees. Now 50% of the question solved. Rest of the thing here. So we are just going to figure out the length of an arc AC. So what is the length of an arc formula? That is nothing but theta by 360. Theta is 80. 80 by 360 into circumference. What is the circumference? 36 pi. Finish. Waiting for the final answer in the chat box. 80 by 360 into 36 pi. So if you cancel the zeros, 36 and 36, it will become 8 pi, right? So the value of this will be 8 pi. We need to find out the length of arc ABC. So length of arc ABC is nothing but the bigger one. We need to subtract the complete circle. From the complete circle, if we are deducting this minor one, the rest of the things is a major arc, right? So complete circumference is 36 pi minus 8 pi. 36 pi minus 8 pi, left with the major arc. Whatever the major arc, the length will be, we can directly find it out. It will be 28 pi. The answer will be 28 pi. See the figure, analyze what are the things we can do. The first thing is we know the property, right? Central angle property. So what is that? Whenever the angle is subtended at the circumference of the circle, the central angle will be double to that. First thing. Second thing is the figure is given before you, and you need to figure out what major and minor by taking out the values, either by adding or subtracting. If it is possible, then we can go through that. From the complete circumference of the circle, if we take off the minor part, then left with major part. So that is the concept what we had followed here. That is the strategy what we have done, right? Okay. Next, moving on to the next slide. I hope everybody are following the session. If you have anything that you are unable to understand, or you want me to repeat anything, you can just put a message in the chat box so that I can go through that. Okay. Right. Second one related to this concept, chord concept, length of a chord being asked. So as per our discussion before, I have explained the length of a chord, that is 2 into root of r square minus d square will be the formula related to the length of the chord. Okay, 2 into root of r square minus d square. Right. So let me explain a elaborative concept, and then I'll go through this formula. So first, let's say what are assume the values. What are the things given? We O as 6, right? O given as 10. Okay, I told you before that is AB will be always AC plus BC. AC plus BC. Now two values are given. If you assume that it as a triangle, I told you whenever there is a perpendicular drawn, the right angle will be formed. Whenever there is a perpendicular lines are drawn, the right angle will be formed. We know that it is 90 degrees here. Whenever it is 90 degrees, we have to apply the Pythagoras. We can apply the Pythagoras concept here to find out the missing length. Okay. So if we apply the Pythagoras concept to find out the missing length, that value will be 100 minus, so it will be 100 is equals to 36 plus CB. We don't know this one, so CB square. So 100 minus 36. So 100 minus 36, 64 is equals to CB square, and CB value will be 8. CB value will be 8. You know that if it is 8, the another part also will be 8. The same thing. So a length of this complete chord will be, what will be the length of the chord? 8 plus 8, 16 will be the chord length. Length of chord is equals to 16. Now directly apply the formula. So if you are unable to remember the formula, you can go through the concept. If not, you can directly apply the formula. 2 root r square 10 square 100 minus d square, that is the distance between, d is not a diameter here, d is nothing but the distance between the center to the chord. The distance between the center to the chord is 36. So 2 root 100 minus 36 gives you the 64 here. So 2 into 8 is equals to 16. I hope you get the answer. Okay, this is how we need to figure out the figures. Whenever we are unable to find out the formula also, we figure out the formula, recollect the formula, you should know the properties. List of formulas for length of arc and all. Already I have shown you the slide, right? So everything, the notes will be shared with you. The handout will be given once the class is done. Okay, no need to worry about that. Okay. So this is all about the circles. We have finished the circles concept. Now moving on to the solid geometry, 3D figures. Okay. In this solid geometry, 3D figures, 3D geometry, all are same. Now, what is solid geometry or 3D figures is nothing but the figures like cube, 3D figures, cube, cuboid, cone, cylinder, sphere, and hemisphere. There are some more shapes like spectrum and pyramid also, but you don't have that in your syllabus, so need not to worry. You just worry about these formulas related to this cube, cuboid, cone, cylinder, sphere, and hemisphere. These are the questions will be asked for you related to these figures. Right. Now, starting with what type of question and what are the things you should understand in this 3D figures. The first thing is to find out the volume, lateral surface area, and total surface area. What is volume? Anyone? Anybody? Quick answer in the chat box. What is volume? Volume of a shape. Volume means, what is volume? Okay, right. So volume is nothing but the simple definition I'm asking, not the formula. So volume is nothing but a space occupied by the figure. Space occupied. Whatever the space occupied by the figure, we call it as a volume. Simple terms. So total surface area, what is, lateral surface area. What does it mean by lateral surface area? Lateral surface area, if you see the room wherever you are sitting, it may be cube shape or cuboid shape. It will not be cylindrical shape or spherical shape, right? Whatever the room you are sitting, it will be either cube or cuboid, not cylinder shape, right? If it is cylinder shape, you cannot survive in that. Lateral surface area, if it is cube or cuboid, if you see the room, whatever the walls are there, that we call it as lateral surface area, excluding the top area and bottom area. Okay, excluding the top area and bottom area, whatever the remain leftover part walls are there, that we call it as lateral surface area. If we talk about the total surface area, it's nothing but the combinedly all the all sides like top area, bottom area, and all four sides in the room, we call it as total surface area. Top area plus bottom area plus lateral surface area. Got it? So volume is nothing but space occupied by the figure. Lateral surface area of any figure is nothing but excluding the top and bottom. Total surface area in the sense top area plus bottom area plus lateral surface area. There is one more terminology used here. Curve used for the figures like cone, cylinder, sphere, and hemisphere. Okay. Now, a shortcut to remember the formulas. How to remember the formulas? So there are many formulas related to this. I can put it in on the screen for the next slide. As of now, we will see how to remember the formulas. Yes. So whenever we are talking about the volume, so volume of any shape can be calculated by area into height. Area into height. Area of that particular figure. For example, if it is a cube, if you cut the cube into slices, the part whatever coming outside will be in square, right? So whatever the formulas related to this square, we are going to apply here for the cube. Volume of the cube will be area into height. In the same way, not only cube, for all the 3D figures, I'm giving just a quick reminder points here. Like volume will be area into height. Lateral surface area or curved surface area can be calculated by perimeter into height or circumference into height. And total surface area will be calculated like top area plus bottom area plus lateral surface area or curved surface area. So these are the quick reminder points what you should understand. Moving on to the next slide here. So you can see that if it is a cube, the volume of the cube will be L into B into H. That's nothing but S cube, right? So all sides will be equal in the cube. So S cube. Lateral surface area 2 perimeter into height. So perimeter, what will be the perimeter of a square? Perimeter of a square will be 4S into S, right? 4S into S. It will be 4s square will be the perimeter of the cube. So next thing is total surface area. Total surface area is top area, bottom area, and lateral surface area. So we know that lateral surface area is 4s cube, and total surface area will be s square plus s square. So s square plus s square plus 4s square gives you 6s square will be the total surface area of the cube. This is how we need to figure out the formulas. Whatever the figure it may be, the shortcut will be helpful, right? You can see the formulas here. So cuboid figure will be something like this, and curved surface area 2h of L plus B, total surface area 2 of LB plus BH plus LH, and volume will be L into B into H. If it is a cube, 4a square will be the curved surface area. Actually, it should be lateral surface area for the figures for cube and cuboid. Okay, 6a square and a square. Moving on to the next slide. Okay. Now there are two questions related to the cube. You can go through that and try to give me the answer for both. Yes. The first question here, if a cube has same volume as surface area, what is the length of one side? If a cube has same volume as surface area, what is the length of one side? We need to find out the length of one side. Okay, right. Volume is equals to total surface area, right? So volume, what is volume? Volume of a square, volume of a cube is s cube, and total surface area of a cube will be 6s square. So s will be 6. Length of a side, length of one side will be 6. Okay. So same thing, a rectangular box has edges of length 2, 3, and 4. What is the volume and surface area of a box? Rectangular box in the sense it's a cuboid. So the formulas related to cuboid we are going to apply here. So rectangular box has edges of length 2, 3, and 4. Waiting for the answer in the chat box. It's very easy. Don't worry, you'll get a handout. Once the class is done, you can go through that. Okay, no need to worry of the previous slide and all. Yeah. Okay. So volume and total surface area of the box. So rectangular box is nothing but the cuboid. Volume of cuboid is L into W into H. So L into W into H, 2 into 3 into 4. So it will be 24. And next thing is we need to find out the surface area, total surface area of the box. So total surface area of the cuboid will be 2 of LW plus LH plus WH. This will be the formula for total surface area. As I have given you the simple tricks, you can figure out the formulas, or else you can learn the formulas by heart. That's up to you. Now 2 into LW. So if you consider it as LW and H, okay. So it will be 2 into 3 plus 2 into 4 plus 3 into 4. So 6, 2 of 6 plus 8 plus 12. Okay. By solving this, you'll get the answer for the second. Now, as it is easy one, I'm just, yeah, moving on to the next slide here. They're running out of time. Yeah. You can see some more formulas. Everything will be shared with you once the class is done. Don't worry about the formulas and all. If not, you can take the screenshot also. Okay, if you want, you can take the screenshot of the formulas also. It will be quicker one instead of noting down each and every formula. So this is the table where all the shapes are being represented and all the formulas are there. Now moving on to the next slide here, we have the question which is to find out the volume of a right circular cylinder with radius 2 and height 4. So we need to find out the volume of the cylinder with radius 2 and height 4. So volume of a cylinder formula is pi r square h. Volume of the cylinder formula pi r square h. So we know h is height and r is radius. So pi into 2 square into 4. So 2 square is 4, 4, 4, 16. The volume will be 16 pi. Actually, the pi's are missing in the complete presentation. Please make a note. So it will be 16 pi. Option C. Next. Next slide. What is the height of right circular cylinder with radius 1 and volume 16? The same thing. So height is missing. We know the formula of volume. Volume is pi r square h. I'm waiting for your answer. I know you can do this. Finish it off and let me know the height here. I'm going back to the chat box. The height of a right circular cylinder with radius 1 and volume 16. You need to find out the height. So please, quick, quick, quick. Yeah. Correct. Next. Next slide. Yes. A solid sphere of 6 centimeters diameter is melted and recast into 8 solid spheres of equal volume. The radius in centimeters of each small sphere is. So one big sphere is melted and small spheres are made out of it, which are 8 spheres, he said. 8 solid spheres of equal volumes are being reconstructed, are melted and recasted. And we need to find out what will be the radius of each small sphere. And for your reference, let me tell you the volume of sphere. Volume of sphere formula is 4 by 3 pi r cube. So here there are two volumes we need to find out, right? We need to find out the volume of the bigger one, bigger sphere, and the volume of the smaller sphere. I am representing that with one bigger and one smaller. Smaller is nothing but the volume of smaller sphere. Now, first thing to find out the first statement answer here. So first thing we had the radius of 6, a diameter of 6. If diameter is 6, then radius will be 3. So 4 by 3 pi 3 cube. And here it will be 4 by 3 pi. What is that? 8. So radius will be 8. So pi r cube, radius we need to find out, right? So pi r cube into 8. So this bigger one has cut into the smaller one, that is 8 parts. So here the values will be like 4. What will be the final value here? If you calculate, it will be like, wait a minute, I think somewhere 4 by 3 pi 3 whole cube, right? So we can put it like this: 4 by 3 whole cube, 4 by 3 pi cube whole pi into 3 whole cube is equals to 4 by 3 pi into r cube into 8. I'm just equating this, right? The bigger one is melted into 8 parts of the smaller one. Now just calculate the value of r and quick answer in the chat box. Make it fast. Yes, answer for this. So 4 by 3 pi, 4 by 3 pi gets cancels from either side, right? So 27. So 3 cube is 27. 27 is equals to r cube into 8. So r cube is equals to 27 by 8. Then what will be the r? R will be 3 cube by 3 by 2 whole cube. R cube. So just cancel the cubes. Then finally r is 3 by 2. 3 by 2 is nothing but 1.5. Option A is our answer. Answer is option A. Okay. Moving on to the next slide here. Yeah. This question is also similar to the previous one. Once you get your handout, you can try this question as a part of your homework, because we are running out of time. We'll see some unsolved questions, whatever we have done in the session. Whatever the undiscussed things are there, if there is any important thing, then we'll just cover it up within 5 minutes and we'll close the session. If you see this question here, a rectangular box has edges of length 2, 3, and 4, twice the volume of the box in quantity A, the surface area of box in quantity B. There are two quantities given. So as I explained in the previous class, last two classes I have been telling that quantitative comparison question has 4 options. Quantity A greater, B greater, both are equal and cannot determine, or the 4 options. Now, twice the volume of the box. What will be the twice the volume of the box? First of all, what is the volume of the box? What is the volume? Rectangular box. Rectangular box volume here will be 2 24, right? L into B into H. Yes, it will be 24. Volume will be 24. Twice of this will be 48. Quantity A. Now, next going through the quantity B, surface area of the box. Surface area of the box formalized rectangular, surface area of cuboid will be 2 into LB plus BH plus LH. So, in the same way, if you do that, LB 2 into 3, 6 plus 3 into 4, 12 plus 4 into 2, 8. By totaling all this, so it will be 20, 26. So obviously B will be greater. Okay, the quantity B will be greater here. Next. Now let's see one question. So this question is also similar to the first one. Okay. Next. Yeah. Okay. So simple question here. The circle C has radius 7 such that 1 is less than r is less than 5. That means r radius is in between 1 and 5. The radius lies in between this range here, whatever the range is given, that is less than 1 and greater than 5. So it is in this range. So we need to find out the area of the circle and circumference of the circle. Let us see what will be the answer here. What is your answer? Whatever you are getting the answer, put it in the chat box. Quantity A greater, quantity B greater, cannot determine. Both are equal, cannot determine. So one thing, whenever there is no perfect value given for anything, whenever there are multiple things you are going to, you have to apply. Like for example, here radius is not given exactly. So it is given in the range. If you take 2, let us assume if you are taking 2, the area, whatever the area you are getting, pi r square, it will be pi into 4. So 4 pi. If you take radius as 3, what it becomes? 3, 9 pi, right? So whatever, whenever your radius is changing, your answer is also changing. That means multiple answers you are getting for whatever the values you are plugging in the value of r, right? So whenever you are getting multiple answers, then you have to put an answer as cannot determine. We cannot determine the exact value of that, right? So cannot determine will be the answer for this type of questions. Whenever the multiple values are to be selected, then we cannot determine the answer for that. Okay. Let's see one question here. Last question of the day today. Once we are done with this. we'll complete the session. If you have any doubts, try to go through the handout once. And if you have any doubts, we'll discuss in the next class. Okay. So here there is a cylinder given and it is cut into some slices. So cylinder is cut into some slices here. Three new cylinders are formed from one big cylinder. Now, how many new surface areas are created? How many new surface areas are created? If big cylinder is cut into small parts, so how many bases are there? First of all, count the number of bases. So how many bases are there? Anybody in the chat box? Quick answer, please. We are running out of time. Yes. How many bases are there? You can see that bases I'm talking about, right? So 1, 2, 3, and 4. So 1, 2, 3, and 4 are 4 bases are there for this cylinder if you cut into 3 parts. So 4 bases. 4 bases are there. So 4 into. Okay, what is the area? Area of a circle, pi r square. So area of a circle is pi r square. Now we know that the radius is 2 here. So that will be 4 pi. So 4 times of 4 pi is nothing but 16 pi. How much new surface area is created? New surface area is 16 pi is a new surface area created. Okay, that's all for the day today. Thank you so much for attending the session. I'm just closing the session. If you have any doubts, you are always welcome for the next session. Thank you.
Thank you, ma'am. Also, I would like to remind you to please register for the virtual loan fair. And if you have any doubts related to the fair or any other query related to our website, please write it on the chat box and we'll get back to you. Thank you, and thank you, ma'am. You all may please
Thank you.
leave the class. Saru and Hassan, you will please leave the class if you don't have any doubts. Thank you.